technology. And so what is wonderful about all of you is that you chose to do a little more in your academics and follow this SEP path. So I was very excited to see all of your projects when we had this showcase of stairs in the cafeteria, and I'm really excited to see these final projects presented. So again, everybody really proud of the work that you're all doing. Deloitte, thank you very much, and Mr. Mueller, thank you. I'm going to introduce Yuna Tsuji. Yes? Okay, from Deloitte to speak. Thank you.
Hello, can you hear me okay? Yeah? Good distance? Okay. Good morning, everyone. I'm really excited to see your showcase. We hear that you've worked really hard on it, throughout the culmination of your years here. So a little bit about Deloitte. So you see a lot of us with our Deloitte shirts. Some of you might have actually worked with Deloitte volunteers in the past. Can you raise your hand if you've worked with any Deloitte volunteers? So a couple. Okay, so some of you know what Deloitte is. Okay, so we're here at Deloitte for our Impact Day. So we get one day a year where we get to take a day off to do a volunteer project with many organizations throughout New York City and also throughout all of the U.S. And here with this group here, we actually work with a group called Pencil, where we partner with actually three New York City public schools. So our Deloitte team partners with you guys at HSTAT. We also work with Community School for Social Justice up in the Bronx, and then Richard R. Green in Wall Street. And so we get to spend the year working with the three high schools, and that culminates in our Impact Day with the three of you schools, and doing great things like this, and continuing the great work that we do. So that's a little bit about us, but on to you guys. We're very excited again to hear about your showcases, and once you're done with your showcase, please come on down, introduce yourselves to us. We'd love to hear more about your showcase, hear more about your projects, and learn a little bit more about you. And if you have any questions for us or about Deloitte and the world of a career in Deloitte, or what it's like out in the adult world, please introduce yourself. But yes, congratulations. You're almost at the end of the school year. Give yourselves a big hand of applause.
Welcome to the HSTAT Software Engineering Program Showcase. My name is Brian Mueller, and I am an SEP coordinator and your MC this morning. I'm a part of the wonderful computer science team here at Tele, consisting of Ms. Guzman, Ms. Meering, Ms. Sukaraya, Ms. Sosa. What we do here would not be possible without them. For many years, students, staff, families, and members of our community have worked tirelessly to lay a foundation for this great program at our school. We have now seen students come and go for 12 years, and many of our SEP graduates are either studying computer science in college or using their knowledge and skills from this program to further society. Between countless hours put into projects and incredibly thoughtful reflections about each topic along the way, I am so proud of the way that all students have shaped this program. Today in the audience, as mentioned, we are joined by volunteers from Deloitte and Pencil, also prospective 9th graders looking to join our program, all of our current SEP students, HSTAT faculty, and families of our showcase finalists. Over the past few weeks, our current students were all given the opportunity to show off their most proud projects from this year at expos for our entire school. And today we recognize a few projects from each grade that exceedingly impressed the judges in the areas of creativity, usability, practicality, and presentation. Now, before we get to the finalists, we'd like to recognize some honorable mentions. In the 10th grade, Jihan Sayeed, Zoya Aga, Luciano Rita, and Winnie Chen. In the 11th grade, Chris Ramos, Essie Awad, Joe Zeng, and Kyle Lin. In And in the 12th grade, Angela Liu, Shelly Wang, Tapas Dono, and Bobby Chan. And though we won't see your project today, you students should be exceptionally proud of what you made this year. Now on to our finalists. We're about to witness 9 presentations, 3 from each grade. Most of you received 3 index cards on your way in, 1 for each grade. So at the end of each grade, I will give you some time to pick one of the presentations to reflect on, and we'll give to the presenter in their bags here at the very end. So please wait through all 3 presentations of the grade before you write anything. In the 10th grade, students begin a long journey in the area of web development. They focus on the front end of websites, which is concerned strictly with content and appearance. Students use industry-level tools such as the cloud-based collaboration software at GitHub, an integrated development environment, as well as Bootstrap to make their websites responsive to any size device, whether it be a phone, tablet, laptop, or desktop. They then pick a topic that interests them, and they study existing technologies in that field, as well as they dream up future technologies. If that all sounds right to you, maybe you're more intrigued by money. If that's the case, you're going to love our first presenter. Please help me welcome Ray Song.
Hello, my name is Ray, and my topic is personal finance. Did you know, based on my survey, 1 in every 7 teenagers are knowledgeable about personal finance, whether that be budgeting or saving their money? I see that as a problem because personal finance is a really useful tool, like, for the future of like teenagers. So I decided to create a website that kind of addresses and solves the issue of financial ignorance. So here, scroll down, you see the existing helpful personal finance softwares and hardwares. So basically, for example, NerdWallet and GoodBudget are like beginner-friendly options or softwares that teenagers may use to like store their money or like manage their money. Here you see the smart wallet and the smart ring. They're like more physical accessories that serve purpose to basically the same thing as NerdWallet budget. They manage money like it's like a credit card, debit card. So down here there's also the adult section. Personal capital and ScanSnap are like basically your tax doers, and they manage and also organize your documents. Next page. Jordan knows money. It's an AI hardware. It's something I thought of, and it's not out yet, but the purpose is it's to control spendings, and it's attached to your keychain. And if you overspend, it will be and alert you that you spend too much, and if you don't listen, it will lock your account. Here's a preview of the hardware. So I use A-Frame. A-Frame is a VR environment where you could use code to create shapes, and with those shapes you could add attributes to them and distort them to your desirable reality. Here, I use A-Scene to create a scene. I use A-Sky to create the background, the gray background. I use the A-Box to create a cube. I use spheres to create face and eyes. So in these shapes, you could see position, scale, color, basically the attributes, and then you can play around with values and to make your reality. So this drink is really cool. So while creating this website, I had a problem, which is I didn't like this format because it looked really boring and basic, and it didn't really match my preference. So I wanted something like this. It used to look dynamical. So I used Bootstrap Vertical, which is basically switching the order of the format. So if I don't have the order code, it will look something like the GoodBudget format. The image is going to be on the left, and the text is going to be on the right. So I didn't want that. So I added the order code, and now I've solved the problem. So while we were creating this website, I had huge takeaways. First takeaway was that don't overdo it. So I hoped that at some point of a teenager's life, you're gonna somehow learn personal finance, but that's not the reality, because personal finance is a really difficult topic to learn. So I created a website, and I hope for teenagers to like visit my website and maybe like learn something from it. Second takeaway is that learning leads to your reality. I wanted to 3D model my AR hardware, so I learned A-frame, and now I know how to create shapes, add attributes, and the final result is I created this. Third takeaway is that basic is boring. From the previous slide, I addressed how I didn't want this type of format because it looked really boring. So I added more code, and now I reached what I wanted. And yeah, that's all. Thank you.
Thank you, Ray. Our next finalist dreams of being a CEO of his own company, and so with a great passion for media technology, give it up for Aaron Williams.
Good morning, everyone. My name is Aaron Williams, and I'm speaking on media production. Yeah, you may be wondering, what is media production? Media production is using raw footage and using powerful tools to create a captivating video for your audience. Imagine a world where Hollywood-level visual effects and seamless video editing fits right into your pocket. In today's digital age, media production isn't just for professionals anymore. In fact, billions of videos are created and shared, many edited right on cell phones. Here are shown many software that is able for mobile, such as VideoStar, Light Motion, and CapCut. Here are shown editing by my friend Joshua King, aka Slim Song on TikTok. And here is my favorite video. Perhaps you want to elevate your own videos but felt overwhelmed by the complex software. You're not alone. Media production, once a new skill, is now accessible to everyone. Us. Today we explore the journey from powerful professional tools like Premiere Pro to user-friendly magic of platforms like TikTok, showing how coding and technology underpin this creative revolution. Here is my website. I list multiple Adobe software such as After Effects, Premiere Pro, and Lightroom. I chose Adobe software as I'm familiar to them, and I have used them multiple times in the past. But I don't also speak on software, I also speak on hardware as well. Such as the Canon G7X, which is used for Instagram photos, videos, and more. Also speak on the RGB light panel, which is often used in movies, YouTube, and more. Here's the boom hole. The boom hole allows you to record sound from long range. I'm going to go to VR right now. Here's my VR. Very complicated sound to get my VR right. Here is my basic brand logo. Right here, 3D. I created 8 furniture graders. With my creation of VisiWrap, all these things will be easier. You won't need multiple hardware or software equipment. Everything will come from your view. It will be easy edited with the use of my built-in AI system. My AI system will not only help you with media production, but also chemistry and architecture. Here's a posting for my VR billboard. I had a white background and I import my image since the VisiWrap 3D PNG. Here is my process. This here is my wireframe for my phone, as used in my website. The importance of wireframes is that it will allow you to have a plan for your website, so it will be easier to do for yourself. And this is for computer. My takeaways have challenges. While software provides tools and creative possibilities, it's the underlying hardware that enables these tools to function effectively and deliver professional results. The better the hardware, generally the higher the potential for quality, efficiency, and creative freedom in media production. I struggled with the direction I want to go through with my project. With that with my friends, I came to my final decision. for your time.
Thank you, Aaron. Finally, in the 10th grade, here to teach you about your own mind is Cammi Wong. Give it up again.
Hello, my name is Cammi and my topic is psychology. So imagine you wake up one morning not feeling you're 100%, and this goes on for weeks or even months, and you can't seem to figure out why. What if I told you technology can predetermine your own feelings, prepare to have your own precipitation of your own mind change? So I'm going to just go through my website. So, I do Snapchat, list group, cards. Okay, and I'm going to talk about my future innovations that I created. So, basically, I created 2 innovations. One of them is called the Chronic Camera, which reads facial expressions accurately to help you figure out how you feel based on the picture. And my favorite is the Smart Support Animal, which is basically stuffed animal therapist. It can be either a bear, bunny, or a cat. And they give you appropriate feedback based on what you tell them. Okay, so my process. I had difficulty with making my title responsive because at first it was not as responsive on phone devices because my title was too huge as well as my quote. So to fix this, I use media queries. So when it hits a specific screen size, my title will turn smaller for that device. And I use APCSP for my animations, which is an animation library that has a bunch of classes for animation. And I will show you some of these. So I use animation on my title and quote, and I also use it on my my logo on the top screen. So my conclusion. So I have a quote. It's called "We can become what we think." So I'm gonna show you. So this helped me with a lot with my project because it was like a huge motivation for me because I didn't think I could do it because I tried my best and I think that's what helped me a lot and motivated me. If I could think I could do it, I will be able to do it. So, yeah. Thank you.
You have now seen all 10th grade presentations. So take some time to pick one presentation and write your name, the name of the project, and a few glows and grows. In the 11th grade, students dive deep into the language of JavaScript. After learning the fundamentals of text-based programming, they create a project using a third-party library. Our first junior had a vision of, at the beginning of the year, of what he wanted to make, and then throughout the year, he quietly made his dream a reality. So here to celebrate that and show you his real-time dashboard is Hernandez.
Okay, so my freedom project originally was called a digital calendar because it was based off of Mr. Mueller's digital calendar where he made a website and he basically made one top half displayed like a photo album and the bottom half displayed a calendar which would have whatever events he had planned for that month. And so I was like, I should do something similar, something that I can maybe tweak a little more to my liking, something that might be more relevant to me. And so first of all, like I said, since this was called a digital calendar, this kind of contains remnants from that. But ideally, my digital calendar, or like my real-time dashboard, would have today's date, it would have weather information, transportation information, and specifically for this project, I chose vehicle traffic. And of course, it would have a clock, because my main issue, my main inspiration for kind of like using Mr. Mueller's idea was, I wake up late every day, and so I want to be able to work on that, and I want to have something maybe kind of like directly in front of me so that I can visualize the time, I can see what the world is going to be like before I go outside, before I even step outside. And ideally, this would be placed in a common area, somewhere where I could see it, but somewhere where like it can also be beneficial to other people who might on the calendar. Sorry. And so yeah, so there were a lot of big obstacles for this project. Bad time management and lack of organization. So like I said, bad time management, I would procrastinate. I would, instead of learning my tool, which was View, I'll get into that later, but instead of learning my tool, I slept, I scrolled on Instagram, I did a whole bunch of other things that I shouldn't have been, and so that severely stunted what my freedom project should have actually ended up looking like. And lack of organization, I didn't even know what my project, like what I wanted my project to look like. But then I finally snapped out of that, and then I realized this is what I want. And so I went into Adobe XD, which is kind of like a 2D modeling software where you can kind of like visualize websites, apps, and whatnot. And so another really big thing that stunted my project was full knowledge of Vue. Like I said, that was my tool that I chose, JavaScript and Bootstrap. And so Bootstrap is just kind of like, it's actually from last year, from SEP 10. It's a web design kind of like interface where you kind of like add little modules, think of it kind of like adding Legos, and it can be for anything like photos, it can be for anything like adding buttons to a website. And so this is actually what I made up in Adobe XD. This is unfortunately not exactly what came to fruition. So over here on the left, we have a Google Calendar. On the bottom is training information, which I did my absolute best to try and get to work, but that didn't come out in the final project. At the top, I think, is the very big thing, where it would pull information from the National Weather Service. And so if there were an alert for, say, all of Brooklyn, all of Kings County, it would display a warning up there and it would say what it's about. Up at the top, we have the clock and the weather of the day. And up here, we have the traffic cameras. So these can actually be pulled from 511 New York. There's a website, and so you just click on a camera, you copy that link, and then you move it into the website. And so there's I-278, and there's Belt Parkway. I was gonna have security camera, but that also didn't end up working. And then the really big one is the weather. So this is what actually came nowhere near as pretty. But we still have the Google Calendar, we have a weather radar instead. At the top, we have the actual weather, so the time when I took the picture, it was 72 degrees Fahrenheit, and then it gives you like a little more information about specifically that day, the weather for that day. And then we still have the traffic camera up there. And of course, because this is meant for me, because I suffer from a lack of organization in general, I kind of added like a little checklist to make to myself. So I added, make sure that I have my keys, my wallet, my backpack, my phone, and a nice little inspirational reminder, don't forget to smile. And so during my coding, I unfortunately had to go back and forth often between my writing terminal and the actual website. And so all of this code, which isn't necessarily relevant, but all of this code is what makes the design, the layout kind of like be the way that it is, and it took me a really long time, but I got it to work. And so my tool Vue is kind of used in websites to be able to kind of like make little applications of sorts. It's not like a mobile app where you can like, it's kind of like meant to like make requests to URLs, which is like what you use to like get to a website, and then pull information from that. And so that's kind of like how I got the information from the National Weather Service or from 511 New York onto my website. And so, oh dear, you can't really read that, but at the top, that's kind of like the line to start the code. Anyways, So here is something called Create App, and that basically creates the little app. And then these are placeholders. This right there says current time. This here says temperature, and so all of these are basically just going to be blank because these are going to be showing on the website if for whatever reason it can't. If for whatever reason it can't pull information from the website, let's say you're not connected to Wi-Fi, it'll show blanks instead of outdated information. Okay, there you go. And so this right here is actually how I got the video player to work. I had a lot of trouble learning this because it was kind of like one step forward, two steps back every time that I would add a line of code. But basically this kind of like tells the code to like be like, hey, go to this link right here, pull the video from that, and then put it onto this website. And then, like I said, with this code, I got that to be formatted into that tiny little square right over here. And so this is how I got the weather to work. This actually took a really long time, and I needed just a little bit of help. So there is one of my peers from my class. I'm not exactly sure if she's here, but her name is Xhenete, where she did a similar project about weather. And she kind of helped me understand kind of like how APIs work, because this information in the green is kind of like a bunch of, it's something called JSON, and it's just kind of like a weird data file, it's a weird text file. And so anyways, I was able to get it to be like, hey, go into this link, and whatever it gives you, I want you to go into something called periods, which is how the data was separated. And think of it kind of like a folder, you know, you go into that folder, oh, I want you to go into this folder inside that folder, and I would go into temperature, and then it would be like, pull that information and bring it into the website. And so it's just kind of like, it really is kind of like a folder, you know, going inside, looking into the files and kind of nitpicking data. And this is how I got the clock to work. This was actually probably one of the easier parts because it's basically just saying set the hours to a variable, kind of like in math where it's like x, set this to x, set this to y, set this to z. And so I was able to just tell it specifically, instead of maybe 13 o'clock, because I'm not really accustomed to the 24-hour clock, I said please give it to me in AM or PM. And so my main takeaways is time is valuable, don't waste it. As much as I came up with something called an MVP, a minimum viable product, I still really wish that I got the training information to work. I still really wish that I got the weather service thing to work. And you have to understand sometimes doing something basic is enough. You don't really have to push yourself too much because I was so focused on getting things that were way too complicated first. I was way too kind of like tunnel vision on it, where I didn't really focus on the website, which hadn't even been fully developed. And don't push deadlines. These are really important. They're not really there to be like a punishment. These are meant to be kind of like a goal for you to have in mind. And unfortunately, I pushed my goal too much, and so I didn't end up with the exact thing that I wanted to. But I'm still pretty happy with how this ended up. Thank you.
Up next is a combination of skill and creativity like you've never seen before. You are about to go on a quest for harmony. Give it up for Chen and Simran.
So my name is Nancy. I'm Simran. So who's ready for some games? No. So have you ever thought about math, music, and in the same sentence? Yeah. So if you enter your name, enter your name. Yeah. So it will welcome you. So click enter options, and you can choose any character you want. Any character you want. Yeah. So you. Here's a new instruction that you click start. It can choose any level. You click any level, doesn't matter. Yeah. So if you run into a red obstacle, and here is a map home. So it's 5 and 6, and you could collect the music notes in each level. Yeah, and the score will increase by a specific number. And if you get rid of each obstacle, you can listen to the music at the end. And then you want to go back home, you can choose another level to play. Yeah, and then you can back to yeah. And then so the tool that I use is called Phaser. Phaser is an HTML game framework, and which is developed in JavaScript. Yeah. So this is a code of how I made our game, which is I made each scene, like each name of the scene, like start scene, credits, and each scene. Yeah. And then in each scene, I have a name for each class, and then in each scene, I have each of the functions, which is called a preload, where I load each image, and then the create function, where I create each image, and each of the scene, I have the switch to each credits, each scene. And then each of the levels, I also have the update function, where most of the physics is behind it. So in the Beyond MVP, where I improved my game, I changed the levels of how the player interacts throughout each level, and also in the beginning, I tried to make the player exit level at the end, but like throughout the level, I made the combat button in throughout level, but like in case the player wants to exit out level and like he or she wants to choose another level.
For me, I use the tool Earsketch, which is basically like a music editing software, but you use like code, like such as JavaScript or Python. I use JavaScript obviously in this case. Like it helps you manipulate things like loops, functions, and like a lot more elements that are also included in Earsketch itself to create songs and such things like that. For me, at first I didn't use any like JavaScript elements at all. I just used what's in Earsketch to make the music or the game. Like this video function helps with inputting tracks like sounds, and this set effect function helps with effects. It's kind of obvious here, but I decided this was like taking too much time. It was pretty unnecessary, so I just decided to use like the JavaScript functions finally, like, such as functions, like which can help create like repeating patterns in the songs, as you can see here. I also used like one challenge I had to face was like it's just like Earsketch is a tool where like you have to edit on its own software, like instead of like on like the CSP, right? And so like I have to edit all of this, and you have to do a lot of like lines of code just to make like a song that's like 3 seconds or a minute long. But I'd say like I made like 5 in total, and I'd say the final product was like worth my time. Like I was pretty happy by the result.
So one of the challenges that I had is like making this game in the middle. But like in the beginning, I had this code where I thought making a file called game.css and making this line of code where aligning items in the center would work. But as you can see, and the game's screen is in the top left of the corner, which I don't want that. I want it in the middle. But I tried many lines of code, it wouldn't work. So a few weeks before, I saw Simran, my partner's game, which her game was in the middle, and I asked her what code she would, yeah. And she sent me this specific code, which would work.
Basically, I had to go back to using Bootstrap, or like CS in general, like when we were learning last year at SEP 10. Like I figured out, like you have to make everything like center, as you can see here, and like make it like sort of a column to make the canvas center, because it's a bit complicated because this is using JavaScript as well, but like I managed to figure it out with the other code and basically.
And it is to this results right here. So these are links to our product, the game, and the game code. So some of the takeaways I learned is break your product down into small tasks I don't know if you noticed earlier, my code, my game took like 1,400 lines of code. It took a very long time, yeah. So my tool Phaser is really sensitive to any errors. Like I have to learn to debug and tinkering errors to pay attention to details. Also, patience is really necessary because, as I said before, it took like 1,400 lines of code. It takes a long time, and it took the whole year. And also, communication and collaboration makes it easier to solve a problem because my partner is in Tier 3 and Tier 4, so it's really hard to collaborate through this process.
My takeaways are kind of similar, but patience and virtue, like, I sometimes I felt like I should like change my tool because your schedule, like I was the only one in the entire step 11 to do that, and also like I had to learn a lot of things on my own, but like I took my time, learned my tool, and I'd say like I was happy with the final result. Like I actually like using ear sketch now. Communication is key. As Nancy said earlier, we were in 2 different periods and we had no classes at all this entire year. So we had to keep communicating outside of school and other ways like texting like that. And like I didn't know what I was doing at first, but I helped again and I actually get my way through the project thanks to her help. And I always review your code, like as like my fellow SEP students know, like once your code crashes, like sometimes, like it's really hard to like find a way out. But like, the more you review, the more you test, the more better you get at coding. And basically,
So thank you.
Alright, our final 11th grade project solves a problem that many of you probably aren't even aware of. Let's hear it for Jacob Levit and Garcia.
Good morning, everybody. I'm Caleb, and this is Jacob. And we created our immigration web app. So, if you look at this web page, you might wonder, what's wrong with this web page? If you're a prospective immigrant coming to the United States for the first time, how are you supposed to read this web page if you can't read English? It's a problem that my mother faced, that my grandmother faced, and that probably many of your parents have faced. So we decided to fix that. Welcome to our immigration resource.
So we decided to build an app which offers rich support for various languages. Our app automatically translates the content according to the user's derived IP address. The thought process behind this being that user most likely speaks the language of the region that they currently are in. And in the latter case, the resource is structured so that the option to manually set the language is clearly available to the user at the top of the web page. So, what tools did we use? We used Node.js and Express.js, React, and Vite for building deployment with React. So, why Node.js? Node.js is a free and open source, cross-platform JavaScript runtime environment that allows for the execution of JavaScript code outside of the browser on a separate runtime environment that runs on the developer's local machine. This way, the code can be run by activating Node server. And Node is ideal for our app because it allows for integration of JavaScript everywhere in the code, both in the front end and back end, whereas you would see other applications using languages such as PHP or Python or Ruby or Java for the server-side backend programming. And this goes into our next tool, Express. Express is a backend web app framework for Node.js, and it's minimalist and fast high performance, actually de facto standard server framework for Node. And it's ideal for building RESTful APIs, which essentially allow for the exchange of data across the internet.
So for my tool, I decided to work with React. React is a component-based UI library that allows me to create my own custom HTML components and input them, so I don't have to reuse code over and over again. It's built for reusability and scalability, and has lots of documentation since it's widely accepted in the professional workspace. So here's a demo of our website. As you can see in our website, you have a manual translation button, which will translate dynamically and will translate the quote, so that no matter where you are, no matter what language you speak, where you come from, you will be able to understand and read our webpage and be able to get the information you need about the immigration process, or about resources and support where you can find that. And so the other thing we included was support for automatic support and automatic language support. So as you can see here, we use a VPN to switch our country. And the country, when it's switched, it automatically, so for this case we use France, and it grabs the IP that it knows is in France, and it changes the quote and dynamically updates it to be in French. So no matter where you access it, you will be able to understand, and you'll be able to switch. And of course, the button should be obvious, because lots of languages, lots of websites have offer language support, but oftentimes it's at the bottom, or it's like in a place that's not as obvious. So we made it was very important to us that the button was in an obvious spot.
So, how did we actually do this? Well, for the minimal viable product, we actually had to test the end goal, and this is a big thing to remember when working on MVPs. We have to recognize the end goal of what would actually happen once we get the user IP address. So instead of focusing first on dynamically actually getting what the user IP address is, we just hard set a value for the pseudo IP address for the user. And then on the next line of code, we utilize another API in our API, this free IP API.com API. And basically appended that variable as a string, so I would put in that money sign and curly brackets because it's a JavaScript variable, but it should be parsed as a string, so that value of that variable is actually recognized as a string, which is appended to that route. So then that's the endpoint that's being called with that variable, which then returns a two-letter region code according to what that IP address value is. So for the minimum viable product, I just made the full stack application in one singular file so it's just Node and Express, no React here, and we just send the HTML response in that same file with the translated text according to the region. This was the only file here. There was just another file for the locales and the different JSON files with those two-letter region codes you pick. But essentially, other than that, it was just one full stack file. And it uses the app.get function in Express on that just default localhost 3000 we call it the slash. So when you run the node server, when the node server is activated, and you just visit the default localhost, that localhost 3000 route, then this is the HTML data that's going to be returned on that route. So for the above MVP, we had to change up some of the code. We had to actually dynamically get the user IP address, which is in this dynamically updatable header, which basically changes according to the user and every time that user makes a request to our API.
So our first challenge, as you can see, Jacob built the backend. It was my first challenge, and our first challenge really was building the front end and combining it with the back end. So for the front end, as I said before, component-based UI library React. If you've ever built a web page before and you wanted to include a nav on multiple pages, you have to copy and paste the code over and over. We don't have to do that with React. We build a component-based library, and once is enough in React. So how do we do this? We make it a component. That we input the component, and then we're able to call it back, and it's just a simple one line of code instead of copying over and over again. We make it the web page load faster and be more accessible and scalable. And our second challenge was actually translating the language.
Yes. So in order to do this, we had to use our API, application programming interface. Application programming interface, which returns the language code for the given region. So it returns the language code on that route right there. On that route, go back. It returns the language code on that given route. Yeah, on that given route, so we deployed the backend on this IP integration website that was called app/API/French language. And when you visit this, whatever your IP address is, when you're making a request to our API, that's what's going to determine the returned region code. So in the next line of code, you see we use this V backend API URL, because basically for V for deployment, there's just something called environment variables. So if you go back to that last one, yeah, that whole entire route, the IP integration website that was called app/API, that was stored in our environment variable. That was stored in our environment variable. And then for the next line of code, when we fetch it in the front end, we still have to append it with the /fetch language endpoint so that we actually get that 2-letter region code. So then we apply the T function, which is a function in IAT, or not in IAT10 internationalization, which is the library for React. We use that T function to find the given name in like that JSON file and then apply a translation. So if you go to the next slide, you see the each JSON file has like a name, you can call it a key, with that given value, which is then which when that file is chosen according to the region code gotten from the API, when that file is chosen, like that matches that 2-letter region code, the T function in IATN applies the translation to whichever given key. So if you go back to the last slide, see that quote pink lane? If you were to have an IP address, detected to be in Germany, then your API would return the region code DE. So then it would pick the DE.json file, and that T function would apply the translation for that one. And then in the lang.js, this is just the file for our manual translation. We need to have all these codes so that you can actually pick the manual translation in that drop down that you saw in our app.
Okay, after all that technical detail, let's get into the front-end part. All you basically need to know from that is that we're able to go back, we're able to fetch the language, and we're able to take it based on the user's IP. That's all I have. You don't need. Alright, so why don't we go? This is where I have the most problems. Welcome to my error land. So first, what I had to do was I had to apply this try function, which is basically, it's saying, please go and fetch the IP and bring it to the front end. If that doesn't work, this was a particularly difficult line of code for me, because if this doesn't work, then we need a backup, we need a default. So we want the default to be in English. So it's like the most spoken language in the world. So we decided to, so for this, I tried to fetch different things. I didn't know how to use the opposite, or the exclamation point, which will basically say if is not a supported language, then change the language to the United States. Because if someone tries to access it in a place where not supported, then we need a backup. Alright, this we use for error catching, and this is very important for us. While you're working a lot with technology and code, it's important to catch your errors. So this helped us a lot to catch when the language was not supported, or when the language was behaving weirdly, differently than we expected. And here's the final thing that we have to do. While fetching, so up here, we're trying to fetch the language from the backend, from the API. So in order to do that, we need to go back and fetch. And what we do is we get lang.code, and we're looking all around, and then we grab the API. Alright, takeaways. Communication is always key. In order for us to communicate, in order for us to actually build this, we needed to communicate in a way that's efficient and we know what we're coding each other, especially when we're working on two separate files. Because they needed to come together, and when we merged them, we had a lot of issues because we didn't communicate enough about what each other was coding and how we were actually going to connect them.
This goes into our next takeaway, problem decomposition, because there are multiple steps that had to be taken along the way of this product to actually get it to the working final deployed stage that it is now. First, like I showed you, I just had that full stack application in just one file with Node and Express, where it just returned the HTML data in that same file. And then later on, when we did integrate the front end and make it a bunch of separate files with the front end and back end integrating React, the automatic translation was working well, and I had all of that finished. But then in the final step, when my partner added the automatic translation, then there was one final step that you take to basically get it to work, like using promise all, to get all of the languages first, to then apply to the automatic translation before the manual translation is set. So there are a lot of different steps that had to be taken and a lot of consideration along the way to really get the final product that we were hoping for. So thank you.
We've now seen all three 11th grade presentations. Make sure in the 12th grade, students have a choice between two different versions of AP Computer Science. And in both cases, students have ultimate freedom over what they can make. Now, I sometimes wonder what high schoolers like more. Money, like we saw earlier, or maybe sleep. So if you're passionate about sleep, you're going to love our next presentation by Shubata Fizin.
Hi everyone, I hope you're all doing well. My name is Shubata, and I created a sleep tracker app that came out of something real I was struggling with, burnout and exhaustion. Now, like a lot of students, I was always tired between school, work, responsibility, and just trying to stay caught up with everything. I was barely sleeping. I'd wake up tired, go to class tired, and even when I did get some rest, I had no idea whether it was enough or if I was just running empty. Now, sleep deprivation was also my quality of life issue. And I conducted a survey throughout the 5 boroughs, and I found out that 90% of students suffer from sleep deprivation. Sleep deprivation is a condition characterized by insufficient sleep sustained over a period of time. My solutions were to create an easy app that could input your sleep, that you could easily log in and give you instant feedback and scientific tips and build healthy habits. So I made a simple but smart sleep checking app. It lets you enter how many hours of sleep you got, and it gives you instant feedback. The feedback isn't random or vague, it's based on conditionals I wrote on JavaScript. If you're sleeping at least 7 hours, the app celebrates that, and if you're getting less than that, it gently warns you. And if you're way under, it tells you directly to get some sleep with urgency. Now, let me walk you through the code that powers it. One of the key parts of this app is an analyze sleep function. This takes your input, how many sleeps you got, and gives you, and runs it through an if-else statement. It decides which message to give you based on your number. Then it updates the output label on screen so the user sees the results right away. I also used an on event throughout the app to make it interactive. Buttons like check sleep, reset, and see tips are all connected to those event listeners. When a user clicks one of them, the screen updates or changes based on what the app should do next. I learned how to make them I learned how to make the app feel responsive and easy to navigate using those tools. Another feature I added was a sleep generator. There's a list of sleep tips stored in an array, stuff like going sleep screen-free before bed, keeping a consistent sleep schedule, or reducing caffeine intake at night. When you click the Get Tip button, the app uses random numbers to select a tip and display it, so every time you get something new and useful. The logic behind my app is simple, but it's purposeful. It doesn't just want something, it's not something that just looks good. I want to make something that actually matters. This was the first time I made something that directly connected my life, and that was very powerful to me. It reminded me that code isn't just for games or assignments. It can actually support your health, your habits, and how to take care of yourself. Throughout this project, I got more confident with things like user input, control flows, functions, and array. But more than that, I started thinking differently about the problems I faced instead. Dealing with being tired, I built something that helped me understand and improve it. The shift from feeling stuck to taking action was the biggest takeaway for me. So in the end, this wasn't just an app. It was about taking something personal, something frustrating, and turning it into a solution. I'm proud of what I built, not just because the code works, but because I made something useful that might help others. Thank you.
Thank you for that. Many of you will probably recognize our next senior who presented in last year's showcase. What he made last year was impressive, but somehow he topped himself. Help me welcome Austin Liu.
Okay, so my project is a molecular dynamic simulation, but you're not going to remember that, so you can call it a simulation. So you do a lot of coding in SEP, but maybe you've wondered by this point how it could be applied to other topics such as physics and chemistry. And in case you weren't, I'm going to show you. So molecular dynamics is just a method for simulating the movement of particles. In my case, I did gas particles using time steps over a period of time. And the best way I could put it is just a physics engine that's used for the purpose of scientific analysis. So this is my product operated by the command line. So it will prompt for the temperature, the volume, and the molecules, which are the main variables for my project. And you'll be able to choose from 6 different atoms. And when you finish inputting the number of atoms for each element, it will start running the simulation. And when it runs the simulation, it's running a bunch of calculations. It's like a few thousand for every time step. And for each step, it's outputting those values into a trajectory file, which will load into a 3D software, which you'll see in a minute. So once that's finished, it loads it into a 3D rendering app, and you can adjust the particle sizes. The colors represent different elements, and you can see when you animate the trajectory, the movement of the particles. So I use Fortran, which is a language that's widely used in these kinds of projects. It's really good for when you just need to do the math really fast. And even though it's not really well suited for anything else, that wasn't really relevant to my project. So this was the best language to use for it. And to represent the molecules in 3D, I use VMD, which is a software that can be operated with the command line. So I just use the script to run that. So molecular dynamics is actually pretty simple. First, you need to assign the positions and velocities to molecules and choose the time step to ensure that the system is stable. Then update the trajectory by updating the position and velocity and other variables right to the file. You do the same for the force and acceleration and the temperature controls, and you do that for as many steps as you need to. So there are a few limitations for my project. First of all, I only model global gases. Since they have no bond potentials and they are non-polar and relatively unreactive, it's very easy to model them since they don't have any dipole moments or other complex intermolecular interactions. And I also don't end up modeling electron behavior because it's too computationally expensive, also it's really hard. So I assume that each molecule is a hard sphere. So in order to update the position, I use the Euler method. You might recognize this if you take calculus, but basically it's just a way of approximating the next position based on the next order derivative. So this is just stating basically. But the thing about Euler's method is that it doesn't conserve energy at all. It leads to a lot of physical inaccuracies and system instability. So instead, I use a different algorithm called velocity relate, which has less energy drift and higher accuracy. And it does this by combining a Taylor series for position and velocity. So the two main things for this algorithm is to first update the position with the current velocity and acceleration, and then calculate the new acceleration to update the velocity. And it's important to do this because you want to use the new acceleration that you calculated with the force for the next time step. And that's just the code implementation for it. In the top part, I'm updating the position with the velocity, and in the bottom part, I'm updating the velocity. So another feature of molecular dynamics is that it simulates an infinite system using a small portion called a cell. And it does this with periodic boundary conditions, which pretty much just means that molecules will reappear on the other side once they exit the bound. And another thing I need to use is the minimum image convention, which means that the closest distance is used between molecules, even through bounds, as you can see. And that's important for distance calculations later. So this is just the code implementation for the periodic boundary conditions and minimum image convention. I just use a rounding function and a modulo function. So to calculate the force, I use a derived Leonard-Jones potential, which models a common type of intermolecular force. It's calculated as the energy between a pair of molecules with respect to the distance. So at small distances, molecules will repel each other, and near equilibrium distance, molecules will attract each other. And for noble gases, which is defined by the blue and the red curve, they have very weak attraction, but they still have high repulsion. So it's still important to include them for the sake of accuracy. So this is what the potential looks like. It contains a repulsive and a attractive term. And epsilon and sigma are just parameters defined by the identity of the molecule. So for a mixture, I would need to use the Lorentz-Berthelot mixing rules, which uses the values for a homogeneous pair. That's a lot, try my best, okay? So for the force, I need to take the negative derivative of potential energy. That involves a unit vector, and the net force is pretty much the sum of the forces on a molecule. So if I had a system of 200 molecules, for each molecule, I would calculate the force between all 199 other molecules, add them up, and then I use that to calculate the acceleration. So I also use a cutoff because at very far distances, the force is effectively zero. So if the distance between molecules is greater than a certain value, I just set it to zero, and that improves the speed of my calculations. So this is code implementation. I use the mixing rules in order to get the parameters, and I calculate the derivative and force. So this is just a demonstration. When the molecules are far apart, they have low attraction. But as they start to get closer, their attractive force increases, and once they reach their equilibrium distance, they start to repel each other. This is the last part, I promise. So the system is kept at a constant number of molecules following the temperature, and even though it's easy to keep the system at a constant number of molecules and the volume, the temperature needs to be adjusted using another algorithm called a thermostat. You can imagine it as like a heat bath. When you increase the temperature of the heat bath, the temperature of the system also increases. So the first type of algorithm I tried to use was velocity rescaling, which uses a scaling factor based on the current temperature. Basically, if the temperature is too low, I increase the velocity, and if it's too high, I decrease the velocity. And that's just the equations I use for this. So I use a helper function to calculate the temperature and use that to rescale the velocity. But the problem with this is that it scales the velocity of every single molecule. That's not something you necessarily want to do because it doesn't give you the correct distributions. So the Maxwell-Boltzmann distribution pretty much describes how many molecules are moving at like a certain temperature. So since velocity rescaling results in individual molecules moving at incorrect speeds, I want a curve like this one. So in order to do that, I use an Anderson thermostat. And since the function for a maximum ultimate distribution is a bit complicated, what I can do instead is use a Gaussian distribution, which is just a standard distribution, and I scale that by the standard deviation, and I can use that product in order to calculate the new velocities, and I get the Gaussian number by using a Gauss-Mueller transform. And this is just the code implementation for that. I use a collision frequency to determine whether the thermostat is used or not, and if it is, I do the temperature control. And I make sure to do that after doing my movement calculations so I don't influence any force calculations. And so a lot of the challenge of making a project like this is that the coding itself is pretty easy, because Fortran is pretty easy. There's actually a lot of resources for it, because something like molecular dynamics is not like web design where tools go obsolete very quickly. So like an article from 30 years ago can still be reasonably used as a good place to learn. So a lot of the challenge was actually the concepts themselves, like the force calculations and such. And also you shouldn't underestimate the difficulty of the project. There were a lot I wanted to add, like pressure control and lock potentials, but I ended up running out of time because these sort of things are really hard. That's about all I have. Thank you.
Austin, I think I speak for everyone in this room when I say we all understood 100% of what you just said. All right. You guys ready for one more? Now, to our 9th, 10th, and 11th graders in the room who have all taken Intro to Computer Science in the 9th grade, you might not know that our seniors in the room are actually the last group of students who had SEP in the 9th grade. So not only is this the first time in history, but also the last time that we've had a student present in 4 consecutive years of the SEP Showcase. It is with great pleasure that I welcome to the stage 4-time finalist, Sharivker.
Alright, hello everybody. My project is called Tirgum Lens. So I combine a mobile app and an Arduino circuit. So imagine this, you're working your whole life, and now you kind of hit rock bottom, you're a little bit alone, you don't have a lot of people to talk to, maybe no more relatives, and you're kind of losing it there, you don't have a lot of people to keep you stimulated, but that's okay, because we have Tirgum Lens, which is a free-to-use global app with a global community, we have games, and we don't sell your data, yet. If egg prices go up, I'm sorry, I gotta buy eggs, so I might have to sell your data, but we'll see. So some of the tools I used was React Native, and React Native is kind of like React and Next.js, except it's made for app development. And I also used the Expo framework, which allows you to use emulators to run your code. I also used Arduino, and Arduino is a microcontroller that allows you to run a certain program, and it can also interact with your device if you plug it in. So this is actually what my hardware part of my project looks like. I also use Firebase, which helps keep track of data and user state. And I also use Express.js for a web server, which you'll see a bit later. So I'm going to use these GIFs to kind of show different parts of my project. So on the left here, we have user registration, and there's a little robot icon, and I use a library called DiceBear, which allows you to randomly generate different profile pictures to kind of give a little bit more personalization. And then on the right here, we can see users typing into our global chat. And the reason why it's a global chat is because the model of the app is that it's supposed to be for everybody to interact with one another. It's supposed to be for community. So that's why we're not really showing as much about like private user chats, which is possible and implemented. So I also have different games. So on the left here, we have Simon Says. And as you can see in this simulation, a user is actually trying to run it, but game over, so maybe they gotta practice a bit more. It was me. And then over here on the right, we also have different memes that users can see, and they all come from r/wholesome on Reddit. That way we don't traumatize the elderly with bad Reddit memes. I think we can all agree that would be pretty bad. So now I'm gonna show the actual hardware implementation. So on the left, let's say you want to know the weather for a different city. So for example, New York City. So on the app, just give it a few seconds. So once I type in New York City on the left, then on my actual Arduino device, it's going to show something. So it shows fog, 84 degrees, and 8 miles per hour wind. So this is what it looks like, an example. So you would see misty weather conditions, 62 degrees Fahrenheit, and 3 miles per hour wind. So we went from on the app to out now actually showing something on a hardware device. So there were some initial limitations. So Expo, which is the framework that I used, it can't directly read serial ports. And the way Arduino interacts with your device is it uses serial ports, which allow you to send data between each other, but my emulator can't access that. And also, my Android emulator can't use Bluetooth. And Arduino Bluetooth is already really funky because of the different protocols you have to use. It's not going to show up in the same Bluetooth search bar that you're going to see on most devices. And you might think that's game over, that's it, no thank you, but we're not done. So all it took was a couple all-nighters and some caffeine, and I thought of a solution, which was to use a web server in between my app and Arduino, because even though my app and Arduino can't directly talk to each other, they can talk to a web server in between them. So the first thing that I did was, on that actual page on my app, I created a post request. And a post network request basically allows you to take data and you're trying to request it to another server somewhere else saying, hey, this is the data I have. I want something back if I give you this. So on that page in the backend, I use a weather API, and this little variable here is just to see that the user implements. I then use some regex expressions which allow me to better format the data that I want so that I just get numerical digits. And now I'm actually making my formal call to the API in this function over here. So now we're working on the actual web server. So the web server is this intermediary between them. So what we have here is a route, and basically a route is just, have you ever gone to a website and you have to go like slash? So if you're in SEP, there's HSTAT SEP.github.io/students. The /students is the route. So when a user goes to the local web server on the route display, then we're actually reading the functions. So now, once we have the actual message which we get from the headers, we're using serial.write to actually write code to the Arduino. And now we're just using port 3001, and this is the actual serial port on the Arduino that I was talking about. So when we get to the actual Arduino, it's written in C++, but the syntax is pretty similar to Java and JavaScript in this context. So the first thing that we're doing is we're starting our serial port on port 9600 so that we're actually able to get incoming data. And we're also setting our font, which is going to matter in just a bit. And now I'm using a loop. So on Arduino, there's two main functions, setup and loop. Setup runs the first time, so right when the device gets plugged in. But loop gets run every single second. So what I'm using here is a method called serial.available. So what it's saying is, as long as there is a valid serial port connection, I'm going to be listening to see, am I getting any text? Am I getting any data? So now what I'm doing on the left is I'm using the font that the user picked, which was me, to actually align on the actual display grid. Because if you looked earlier, the display was very small. So we had to make sure that we handled text wrapping and that there was character limits. So that's what we're using here. We're basically just seeing how many characters can I possibly fit on this line, and then based on what the user types in, how do I wrap this text? So raise your hand if you like it when your code runs. Well, it don't run. So there were now a lot of challenges. So the first thing was errors with no logs. React Native does not like to give you logs. Nothing running here, no error logs. Can you spot it? I can. Maybe we need the map from Dora or Google Maps because we cannot find that error. It's nowhere. Sometimes just doesn't like to run. It's a little quirky like that. You gotta flip a coin. Maybe it will, maybe it won't, but that's the spice. So what are some solutions? So the first thing was relaunching the emulator and resetting the snapshots. So I use an Android emulator, and sometimes it likes to save its code from the previous state to try to run a little bit faster. But the issue when it does that that is it doesn't end up actually always updating your code. So if you do fix a previous bug, it doesn't update. So that can cause you some issues, so it's good to start fresh. Also, deleting your node modules, so the libraries that you use, can help you get a fresh start, especially if you were updating or you had some previous version issues. And the last one was flipping a coin. Sometimes it likes to run, sometimes it doesn't. So also I had some port issues. So ports are doorways into your network. It allows for different incoming connections to be received or denied. So as we can see here, we have an open door. Anybody can use this port, it can receive and send data. But on the right, the door is closed, the port's closed, you can't use that. So originally, I was trying to use port 5000 on my server, but it turns out that on Macs, iTunes, which is an app and service, is already running on that port. So I didn't know this at first, but what I had to do was I had to run this bash command, and basically what it does is it just checks all the network processes on that port. So whatever's happening, if you see something, it's gonna pop up, and if you don't see anything, that means there's nothing running there. So in my case, there was something, which is why it wasn't running right. So what are some takeaways? The first thing is, don't use React Native, go native. What I mean by this is, if you wanna make a mobile app, make the app for the platform. So React Native tries to do both, Android and iOS, all in one place, which although it is very convenient, you are limiting yourself eventually to long-term features, and also you do experience some more issues if you just go platform. So there's other alternatives like Flutter, which use different formats, but usually your best case is to actually go native. And if you can't find the documentation, you have to become it. So what I mean by this is, my tool didn't have a lot of useful documentation or videos that were modern, so I had to really work with what I had and spend a lot of nights trying to debug everything and getting my code to run. So if you don't have the online resources, you just gotta work a little bit harder. And don't let hard challenges and frameworks let you quit. I'm sure a lot of my classmates saw me banging my table in class on Mondays or yelling at my computer, but in the end, it was worth it. And that is part of life. There's a saying that if something was easy, it's not worth doing. And I totally agree with that. Sometimes you just gotta keep pushing through. And I have some wisdom, which is that at the end of the day, it's the end of the day. Thank you.
All right, thank you, Chen. So you've now seen all 12 great projects. So take some time to pick one presentation, write your name, the name of the project, and a few goes and grows about the presentation or the project, and hold on to it for just another moment.